So I made the concept map. It looks a bit as a huge battlefield and a bit overcrowded, but let's go together and understand how all the SSI entities and our SDK concepts connected together. So sorry for coughing, I catch the COVID, so that it will be a bit of coughing session. So as you see, we have in SDK we have three big players. So it's more not even players; it's more the roles. So I talk about this in my previous videos, but we have the verifier, we have the holder, and we have the issuer. As you could see on the map, these green circles actually is the instances of our SDK. And they for sure could be much complex than just the SDK instance. They could have custom business logic, but what the more important, they do not communicate with each other directly. So they communicate with each other via this blue arrows. So it's our exchange protocols. So in exchange protocols, we define the entities, but we are transport agnostic. So what that means? That in theory, you could generate the QR codes, you could generate the JSON payloads that you will share via HTTP, you could use the DITCOM tool, you could use messaging, you could use a lot of different things. For example, messaging, it's yet another stuff that we offer as a part of our solution. So, and we will focus actually on entities itself. So the entities, it's this round circles, and you know, everything that data points. So it's connected somehow to the entity. So, and that's probably it. But let's focus first on the holder side. I already described you a couple of times that we actually have the wallet. So take a look to my video that describe what happened when we create the wallet, and the main entity in the wallet actually is the seed, and from the user seed we could recreate the private keys of the users, and these private keys have the same cryptography as the Ethereum, Polygon, and Bitcoin network, so they are blockchain friendly. And in theory we could generate more keys. Depends on the metadata that will be friendly with maybe some other blockchains or some other systems, and for sure every private key have the public key. And when we creating the wallet for you from the private keys and public keys, so the public keys we distribute via the DID. So we form the DID document, and we use something like called the DID anchoring that allow us to grab the DID document and connect with the DID identifier depending on the DID method. So the DID method could actually drive the implementation, how to do this process of deriving the DID to DDoc, so these arrows. And in theory, method implementation could be blockchain connected or off-chain connected, or for example, some DID methods use the IPFS, and maybe the IPFS together with the blockchain. And usually when you get the DID, it's always work like that you go to some kind of registry or resolver and gets back your DID doc, and from the DID doc you get the public key. So that's actually it. So it's the most important connection between your private identity and your public identity. And as you will see, that the DAD actually connects everybody. So if you see the verifier have the DAD, and verifier include the DAD as a request sharing that goes to the holder, and issuer DAD actually is the part of your VC that you get from the issuer. So it's always a part of your VCs that you hold. And actually, if verifier, if issuer decide to share some VC with you, so we will focus on this flow right now. So let's imagine that issuer decide to share the VC with you, so he will make the request for offer. We have the separate video that describe how to do requests for offers, how they looks like. But here, uh, issuer sent to you some rendering info, and what most important thing, that VC types that will be shared with you. So VC types will be the part of the VC in the future. So, and what happens that actually issuer share the request for offer with you. You analyze this request for offer, decide that yeah, it's nice. You forward the response for offer, and this response for offer gets signed with your private key, and you include your DAD to the response for offer. And what's more interesting connection, that response for offer will contain the request for offer, so they will be interconnected. So it's a complex GVT token, and in this case the issuer could verify that these two guys are correlate, and actually you already shared your DAD with you, so he could issue the VC to you for your particular DAD. So we have the separate video that actually describe this process, and actually you get the VC, and here we see VCs as blue, so it's the part of the exchange actually entity. So it could be used as an exchange between the issuer and the holder. So it's the last step. As you could see, VC contain a lot of different things. So VC contain first of all the schema that set the context and meaning of the data. Was what more important, it's contained the claims, so it's the facts and data about you or some other things that you want to share with others. So it's the way how you extend your identity, not only with the public keys but with the facts about yourself or maybe about the other people. It will contain the DAD of the issuer, so this connection between VC and issuer actually going via DAD, as I already mentioned, and another connection between the issuer and the VC actually is the proof. The proof contains the signature that was made by the private key of the issuer, so you have the special proof, and it's the part of your VC. So you have the schema, you have the claims, you have the VC types that say what kind of VC you have, and yeah, all this data, as you see, it's quite complex. It's quite complex data graph connected together form the VC. And most important part is the proof, and you see that we have couple of proofs. So what's the difference between these two proofs? That proof of the VC actually is the proof of the issuer, so it's signed by issuer. But let's imagine that we have the verifier that wants to get some data about you. Yeah, so he formed the request for offer. So he formed the criteria, what kind of VCs he wants to see, and one of the criteria, for example, could be the VC types. Yeah, and he signed it with his private key, and he include his DID to the request for sharing, and send this request for sharing to you. And you could analyze your wallet, find the VCs that you want to share, and you produce back the verifiable presentation. And verifiable presentation, as you could see, will have the schema too, will have your DAD, will have the bunch of VCs that we want to share, and for sure it will have the proof. But the main difference between the proof of VC and proof of VP, that first of all, this proof will be signed by you, so you proved your ownership via the signing. And what's more important, this proof will contain the request for sharing. So this request for sharing will be included as a part of proof. It means that this VP could be validated and read it only by guy, and that actually ask you the question. So it's quite important to understand. And as you see, we connected all blue dots. We have a full cycle that issuer actually issuer actually issue you the VC, and somebody asks you to share this VC, you produce the VP and send it to verifier, and then verifier could do all the magic. As you can see that verifiers and issuers have the same. They have the public keys, private keys, they have their DIDs, and they could actively use the registry to resolve their DIDs or some other people DIDs. And what's more interesting part, it's the connection of your self-sovereign identity that represented with the DID and your VCs, with some identities that are Web2 or identities that are came from the physical world, and it's one of the main benefits of actually Affinidi SDK, that we build a couple of things that allow us to, first of all, build the H wallets, and H wallet could store the seed and do all the operations just itself. So it's self-contained, it's good enough, and everything is stored on the H wallet, and so on. But we offer something more interesting. You allow to connect your Web2 identity, like email, for example, or maybe some OpenID or OADC compatible providers with your DID and with your VCs, because we have the separate user management, and user management actually allow to convert the phones, emails, and OEDCs providers to have your actually Web3 or let's say Web5 identity, because this private and public keys actually is the shared part. So this is the same mechanism that actually the Web3 will use. So, and even more interesting thing that, for example, you could build the Edge wallet on mobile that connect your biometric data like fingerprints or face recognitions together with our user management. So you could connect your biometric IDs together with your SSI identities and verifiable data. So it's a quite interesting thing, and it's quite mind-blowing that you could just have your phone, or you could just have your fingerprint, and gets back your VCs about yourself and VCs about others, and actively share it with other people. So it's that's it. So that's it that I was quite keen to share with you today. So just to recap, that you have your public identity as a DID, and you have your private identity as the private keys. We allow you to connect your physical and Web2 identities together. But yeah, I forget the most interesting part of the story actually. And this most interesting part of the story is trust registry. So we talk a lot how we connect the issuer and holder, and how we connect the verifier and holder, but how we actually connect the issuer and verifier together. So let's imagine that the verifier just get the VC. He really confirmed that this VC was signed, was the key that was mentioned with the GAD that we have. But what else? What I could say about this DID, and how we could, for example, connect the metadata to the DID, or for example, how we could form the list of the trusted DIDs that we actually accept and trust to them. And for this, we actually could use some third-party system that is a trust registry that have the list of the DIDs with some metadata that have a meaning for verifier and for the issuer, and these two guys actually could exchange their pairs of the DIDs and make this connection happen. And this connection is most interesting and intriguing part of the trust triangle. and we will talk a lot about this, but right now is the set party system that should be implemented by the verifier or by the issuer, and they should trust to each other. So it's a most interesting piece of all these connections. And yep, so that's it. I will share the SVG of this mind map with you, or the concept map, and as you see, we have all the things interconnected, so we could follow how the, for example, the VC types are connected to the different entities, and how some other entities are connected. So I believe that it's a bit messy, but it's a bit useful to understand how the different data points connected to the entities and how the entities interact with each other. So see you, sorry for coughing, and see you in my next